This video I will be discussing shear strength and shear stress of soil. Why shear stress only or shear strength? Why not compression? Why not tension? Why not bending? This is the first question which arises to anybody, that why we are not discussing the compression, tension or bending of a shear of a soil. The reason is these three are not applicable to soil, because if you take a soil element to discuss its behavior, it will not subjected to tension or bending in any way, okay, because it is surrounded by the soil everywhere. Clear? Now the third part, compression, is also not much applicable because it will not fail in compression. Okay, so the only thing which can happen is shear. That's why in soil we are mostly concentrated ourselves on shear. This becomes a very important part of soil, because without understanding this you cannot understand lateral pressure, stability of slope, and foundation, deep or shallow both. So this chapter is the most important chapter as far as the concept is concerned. You have to pay maximum attention to understand this chapter, because this will be the foundation for these three chapters. See, the shear strength is given by coulomb and shear stress part will be given by mohr. What we will do, we will understand both and combine them to make our theory. Okay, so first it is very important to understand the difference between strength and stress. So I request you to watch my video Theory of Failure, where I have explained the difference between strength and stress. I will discuss little bit part of that, but not in great detail, as I have dedicated one video to make you understand the difference between strength and stress. Each part has its own strength, and when load is applied, it develops stress. And when the failure will take place, failure will take place when stress is just equal to strength. Okay, so let us take the first part, which is strength, and then we will study stress, and then we combine it. So coulomb, before coulomb, let us understand the shear by a simple example of friction. So for friction, if you see, if I have to move this block, then I have to apply a force F. Okay, now this weight of the block is taken as sigma. Clear? Then what will happen when this F will increase slowly from 0 to the point where this block moves. Okay, so this F is now function of sigma and something which is here or here. which I call it phi. Okay, that is the frictional part. Clear? So let us see. So if you see this, when I have to move this block, means I have to develop the shear. Clear? When I am moving this block, then the forces will develop, which is Fr, clear, and Pn. Okay, so Fr will develop because of Fa, and Pn will develop because of Pn. So Pn and Pn is same, but Fr is not equal to Fa. But what will happen? This Fr will be equal to P10 delta. Okay. Now this delta will increase till the time the block will slide. So when this block will slide, we get Fr is equal to P10 phi. This is a simple problem of friction. So I am not going into the much detail. I just want you to understand that the frictional force which develop depends upon this Pn. Clear? More the Pn, more will be the friction. It is very simple. If you have a bigger object and if you want to slide, you need more energy, and if the object is lighter or small, you need less energy. Clear? So Fr, which is my now shear strength, becomes sigma 10 phi. Here, if you see, I divide it by area. Clear? So this becomes S is equal to sigma 10 phi. Now this is for block. But what Coulomb had said is important. Coulomb has said that the shear strength of the soil depends upon 3 parameters, and he numerically said this value is equal to S plus sigma 10 phi. I again repeat, we are talking about strength of soil. So strength of the soil is governed by S is equal to C plus sigma 10 phi. Now C is the part which comes due to the cohesion of the sand particles or soil particle. I am sorry, it is because of the soil particle. Sigma is your stress particle part, which is the friction resistance, and phi comes due to the interlocking of the soil particle. Okay, so Coulomb has said that S is equal to C plus sigma 10 phi, and please remember again that this is a strength, not stress. This is not stress. This is just a strength of soil. Now, after Trezaki, we come to know that this sigma is not total, but this is effective. Is it okay? So now my equation for numerical part will be S is equal to C plus sigma effective 10 phi. Or I have already discussed how to find effective stresses. So sigma effective is sigma total minus U. So U is the pore pressure. Is it okay? Now when we come to the different type of the soil, we find that if we plot S is equal to C plus sigma 10 phi, then what we see? That C is 0 for cohesionless soil. So how my graph will be between S and sigma? So this is my S and this is my sigma. So graph will be C is 0, so S is equal to sigma 10 phi, a straight line passing through the origin. Now for cohesive soil, this phi is 0 when there is no change in the drainage condition. Is it okay? So S becomes C and phi becomes 0. So this is a horizontal straight line. and this is a simple inclined line for the generalized case, which is cohesive soil with the change in condition. I will discuss these things one by one again, so do not worry about it. Clear? So my important part is that S is equal to C plus sigma tan phi is my strength. So what Coulomb had said now? So Coulomb has given S is equal to C plus sigma tan phi, and this is strength. Now come to the mohr part, which is stress. So if you see this part, then this is my ground level, and I am considering one element here with sigma 1 stresses, and due to lateral pressure, which I discuss in the coming video, is sigma 3. Okay, if you see, you will find the diagram here, which you have might be studied in strength of material also, that if I have sigma 1, sigma 3, okay, and now I am finding the stresses on a plane which is making angle alpha with the major principal plane, which means that this is my plane. Okay, the angle is alpha. Please remember that this angle is with the plane on which major principal stress is applied, which is sigma 1. So sigma 1 is my major principal stress, and sigma 1 is greater than sigma 3. This is very important. Clear? So if you see again, this angle is alpha, and I am finding the stresses, which is a normal stress and shear stress on this plane, making an angle alpha with the major principal plane. So this is my major principal plane. Major principal plane. So I will not go into the detail of this part also, because I will when I will be discussing mohr circle and mohr stresses in strength of material, I will derive the formula. We will use the formula here directly. So sigma n, which is my this part, is equal to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos of 2 alpha. Remember. Okay, and tau, which is my this part, so tau is sigma 1 minus sigma 3 over 2 sine 2 alpha. Now I am able to find the stresses on any plane making an angle alpha with the major principal plane. Is it okay? Which is sigma n is a sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos of 2 alpha, and tau is sigma 1 minus sigma 3 by 2 sine of 2 alpha. Now, so if you take, if you want to do it by mohr circle, then please remember every point on mohr circle is a plane. Okay, so this is a plane which is sigma 3 comma 0. Actually this is this point. Okay, similarly this is this, and make a correction, it is sigma 1 minus sigma 3 by 2. So the radius of the mohr circle will be sigma 1 minus sigma 3 by 2, and please remember this, and the coordinate of the center will be sigma 1 plus sigma 3 by 2. Now as I said that each point on the mohr circle is represented by a plane. So if I consider this point, which is sigma comma tau, clear, making an angle alpha. Now it is important to find from where we are measuring alpha. So there are two concepts in Mohr circle from where you can measure alpha. One is from the center, but you have to remember that if you are using the center part, then the angle will be twice of alpha. Okay, don't worry, I will make a complete video of Mohr circle and Mohr envelope when I will be discussing strength of material. But there is another way of doing this, which is by pole method. So this is my pole. I will in next video I will discuss how we get the pole. So if this is my pole, then making a angle alpha, okay, will give you this sigma comma tau. So without doing the calculation, also by drawing and graphically, I can solve the stress problem. Now in engineering you will see lot of graphical solution. The reason is that in the ancient time people do not have the calculators or the computers. So if they have to do lot of numerical part or lot of iteration, then they mostly rely on tables and graphical solution. So this is one of that. Now at every time if I change my alpha, then the formula will change and I have to use the calculation to solve this, and calculation will be very tedious if I do not have the calculator. But in this case, but if you use the graphical solution, then every time you just have to measure the angle and you will find the stress. That is why you will see lot of graphical solution in the engineering part. Now they are less relevant, or we can say that we by softwares we can directly find it, but at the ancient time when there is no computer, they are the real life of a engineer. So lot of graphical solutions has been developed for each and every theory. Clear? Okay, now coming back to our main part. So what Mohr has given? Mohr has given shear stress tau as sigma 1 minus sigma 3 by 2 sine of 2 alpha. Okay, and sigma n is sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos of 2 alpha. Now things become very interesting. Now if you see, this sigma is actually sigma n. Okay, because my block which I was discuss here is not like that, but this is this plane. The block is on this plane. Okay, so the block is not resting like this, but the block is like this with sigma n. Now if you see, the strength increases as my sigma n increases. Is it okay? So now strength is directly related with the stress, since this sigma n is a part of stress. Clear? Okay, so this becomes very interesting part. So this becomes very interesting that as my stress increases, my strength also increases. Is it okay? Now if I combine both the theories together, now if you see, S is equal to C plus sigma n tan phi. Okay, now if I put the value of sigma, what I get? C plus sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos of 2 alpha into tan of phi. Okay, and this is, remember, this is my strength. And what is my stress? My stress is tau equal to sigma 1 minus sigma 3 by 2 sine of 2 alpha. This is my stress. Now, for the given condition, S minus tau will be minimum when del S minus tau over del alpha equal to 0. Because if you see, alpha is the only factor which is variable for a given condition. Means sigma 1 is constant, sigma 3 is constant, phi is constant because this is a soil property. Is it okay? So what is the only thing which is remaining? Alpha, which is infinite planes on which failure can take place. So if you solve this, you will find that alpha comes out to be 45 plus 5 by 2, and this is very, very important. Okay, so the plane on which failure will take place is 45 plus 5 by 2. Failure plane. Okay. Now, if you see, this is my mohr envelope, and on failure, this is my mohr circle, and this is the failure. So this angle is 90 plus phi, because this angle is twice of alpha. And if you see this angle, then this is 45 plus 5 by 2, and this is my pole. Clear? This is a very important formula, friends. Lot of objective question has been asked, and I will be using again and again this formula, that the failure plane is at 45 plus 5 by 2. Is it okay? How I arrived? I have just given you the derivation part little bit. I have not solved this, but I have said that this result will give you alpha equal to 45 plus 5 by 2. Okay. Now, so coming back, so alpha is equal to 45 plus 5 by 2. So failure, this is my sigma 3. And this is my sigma 1. Okay, and this is my plane. So the angle the plane will make is 45 plus 5 by 2. This is my sigma n, and this is my tau. Now this is the condition where S is equal to tau. Is it okay? Because we said S minus tau is minimum. Clear? Now, if you see, what is my S? S is, if you see, my S is S plus C plus sigma tan phi. Now, if I put this sigma here, so what I get? S is equal to C plus sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos of 2 alpha into tan of phi. Now since S is equal to T, I put T equal here. Is it okay? So what I will say, that T is also equal to this. So what I get? Half of sigma 1 minus sigma 3 sine of 2 alpha, and put alpha equal to 45 plus 5 by 2. Okay, I am going more into the detail part and derivation, and not coming to the objective, but this is very important to understand how we are getting the equation. Okay, so if you see, if I put S is equal to tau and put these values, I get a very good equation which is very important for objective. If you simplify this equation, you will get this. This is the most important equation, friends, because this will solve lot of your numerical problems. So finally, when doing everything, what we get is sigma 1 failure, which is the failure criteria, is equal to 2c tan of 45 plus 5 by 2 plus sigma 3 failure tan square 45 plus 5 by 2. Okay, now just try to understand what does this mean, and just understand why this equation is very important. Let us say this is my ground and this is my soil element, which is applied everywhere sigma 3 due to lateral pressure. Now I am constructing a building or a dam, whatever it may be. Okay, so I have some construction and load is coming. Because of this, there is a additional stress sigma 1. Is it okay? Because of this project, I have additional stress of sigma 1. Clear? So what can be this value sigma 1? This is governed by this equation. This value cannot be more than this sigma 1, otherwise the failure of the block will take place. So by this equation, you can find what is the maximum value of sigma 1 at that particular soil element. Okay. Now for objective part, if you see this value tan square 45 plus 5 by 2 is known as flow value, which is represented by n phi. Okay. So now I can write this equation using this part as sigma 1 failure is equal to, this becomes root of n phi and this becomes n phi. Okay, so what we get, sigma 1 failure is equal to sigma 3 failure n phi, which is flow value, plus twice c root of n phi. Is it okay? Clear? So this is my first thing. Second, if you solve it for sigma 3, you will get 2c tan 45 minus 5 by 2 plus sigma 1 failure tan square 45 minus 5 by 2. This you don't need not to remember. Just try to remember this one. Okay, then every problem will be solved. Is it okay? Now the second important part here is angle of obliquity. Okay, the failure will takes place at the maximum angle of obliquity, which is given by tan delta maximum is equal to tau f by sigma f. I tell you by Mohr circle what does this mean. So let us solve it by Mohr circle. How to find the maximum angle of obliquity? This is the numerical formula. And let us say this, and failure has taken place at this point, which is sigma comma tau. Okay, then the angle of obliquity will be this. Okay, this is my delta max. So what is my delta max? This is tan delta max is equal to tau failure. So this is the failure part. So tau failure over sigma failure. Is it okay? This has been asked two times or three times in IES. Okay, or what we call it ESE. Is it okay? So this is angle of obliquity. Now if we take cohesion-less soil, so for cohesion-less soil, C is 0. So what my equation will become? sigma 1 is equal to sigma 3 10 square 45 plus 5 by 2. Okay, and if I simplify it, okay, so what I get, sigma 1 over sigma 3 is equal to 1 plus sine phi over 1 minus sine phi after simplification. Okay, so you can remember this to save the time, because many a times it has been given that the soil is cohesionless or the soil is sand, so you can directly apply this formula or this formula also. This is just a simplification of the formulas. So what we can say, if sigma 1 and sigma 3 is given to me and I have to find the angle phi, then it will be sine phi is equal to sigma 1 failure minus sigma 3 failure over sigma 1 failure plus sigma 3 failure. Is it okay? Just very easy to remember. The minus will be above and the plus will be at the denominator, because the value should be less than 1. In this, plus will be above and minus will be below, because sigma 1 is greater than sigma 3. Now, as per as coulomb, the C and phi. So phi, I will discuss phi in great detail in the next video. Is it okay? So phi and sigma depends upon the past history of the soil, initial condition of the soil, which is soil saturated or unsaturated, permeability of the soil, and drainage condition. I will take one by one this and the type of test. So friends, this is the first part of the shear strength, where I discuss the main concept of stress, failure criteria, and mohr envelope. From the second part, I will be entering into the more practical uses of this, why we require different tests for the soil. Okay, if you like my video, give a thumbs up. If you have any suggestion, write on the comment section. If you have any query or any doubt in the video, you can WhatsApp me on this number. I will be ready to help you. Thank you. Enjoy civil engineering.